Welcome everybody to another space with Harry, co-founder of Gensyn on the Gensyn X account. It's going to be a fantastic one as Harry has recently released a brand new article of Delphi as a Meta-Optimiser for ML systems, which is pinned to the top of the space if you haven't read it yet. Harry, I'll pass it straight over to you.
Perfect. So yeah, I guess firstly, I'd recommend everyone kind of open the article, have it as a reference for this session, as I'll refer to it periodically. And secondly, just want to say, thanks everyone for joining. It's good to see a lot of recurring faces in the space, and we will be doing more of these as we approach mainnet, which is coming up next month in April. So yeah, to kind of dive into it, I think the purpose behind this article is to elucidate some of the thinking that I and we at Gensyn kind of have around the role of prediction markets as they relate to machine learning, particularly machine learning training. The Gensyn kind of story so far has been we were more explicitly focused on doing peer-to-peer decentralized training in the kind of more explicit sense last year and for the kind of years before. People who ran RL Swarm, which was our RL post-training system throughout last year, would be very familiar with that. But also we continue to release just lots of research content and artifacts around decentralized training more broadly. Our goal has been for a long time, from our inception, to scale machine learning, and we think that one of the primary ways to achieve that is by doing training in a decentralized way. But with time, we've kind of we looked at different ways of doing that, different strokes, from more theoretical approaches, which we've released in papers. You can look at papers like No Loco, for example, Skip Pipe. They're all at gensyn.ai/research. To approaches which are more kind of first party and practical. So people who have their own model that they want to directly train, you could do that in RL Swarm, which, as I mentioned, we focused on last year. But then more recently with Delphi, we view this as a continuation of that thinking, particularly as it relates to reinforcement learning and continual learning too. So the focus of this chat is to basically describe an update to our thinking around why decentralized prediction markets, Delphi in particular, is a good meta-optimizer for machine learning systems. To kind of level set the room here, I'm going to just define a few things up front, because I think these conversations are often helped with shared knowledge, given lots of these words are kind of pinged around today, and they can kind of be misinterpreted. So when we think about kind of prediction markets initially, like, what are we talking about? A prediction market, like, simply is the ability to gain financial exposure to the outcome of a certain event. So classics in the space currently are sort of Polymarket and Kalshi. They've taken like slightly different approaches. So Kalshi kind of structured more as an options house, whereas I believe Polymarket still kind of has its crypto roots. It defaults down onto Polygon POS. So that's a prediction market. Crucially, these are centralized prediction markets. So the organizations, Kalshi, Polymarket, they create the markets, and they maintain them, and they incentivize people to deposit liquidity, etc. Decentralized prediction markets take the same concept. So you're gaining financial exposure to an outcome, and that outcome might be something like, will it rain in Los Angeles tomorrow? Will XYZ team win the Super Bowl? Will someone say a certain thing or change an opinion in public? These markets can benefit from being decentralized. And a decentralized prediction market really kind of has, in our opinion, three qualities. One is that anyone can kind of create a market. So as opposed to there being this kind of permissioned centralizing force, which says, okay, we're only going to do a market, on, will this team win this sporting contests, anyone can make a prediction market over anything. That's point one. Point two is on the training side, that the markets themselves have the kind of DeFi quality of being financially free, financially liberal. So people can, if they want, without KYC, use the service. Very similar, as you could imagine, to dexes like Uniswap, for example, compared to the more centralized exchanges like Coinbase, etc. The third and final point on these prediction or these decentralized prediction markets, which matter, is that they find a way to achieve trust in market outcomes, and this is a very important point because it touches on why we think that these are very, very good first use cases for verifiable machine learning. And anyone who's kind of been following our work for the last 6 years will know that verification to us, both in terms of machine learning training runs, but more generically, but also just in terms of being used to verify the outputs of machines for inference and for all the inference related use cases, has been a big focus. And papers like Verdi, which we released, which you can see at Gensyn.ai/research, were in support of that. The crucial thing here, though, is if you obviously have anyone creating a market, you might not trust the person who's created it, even if you want to trade the market. In the centralized setting, you trust the house, as it were. So you trust, Polymarket to settle it in your favor, or Polymarket's sort of protocols that they default down onto, like UMA. In this case, there needs to be stronger trust guarantees in a decentralized setting, and that's achieved through verifiable machine learning. So the markets are settled in the Delphi case by rerunning a model which is able to produce the outcome, and then the outcome is what should ultimately be used to settle the market. So those are three things there which kind of are important. One is decentralized market creation. The second, permissionless market creation, that is. The second is permissionless trading, so anyone can kind of come and trade in the market. And the third is the benefit to having verified settlement when it relates to machine learning models. So that's a decentralized prediction market. There's a nice quality that a decentralized prediction market has, which is, because anyone can create a market, you then get more rich markets. I think this is intuitive to anyone. You can think of it like, in content creation more broadly, as opposed to there being a set of, 100 TV channels. In kind of the older days, now you have infinite channels on YouTube, and that is, broadly speaking, a better consumer experience, because there are small communities who are niche and who are well aligned with those channels. And that leverages a kind of concept called the thousand true fans theory, which has been highly popularized with things like OnlyFans, where you can kind of create these very niche sort of like subcultures that people will follow. But also more broadly, just streaming culture, as I mentioned before. You can make a living on the internet having a relatively small group of people who are highly engaged with the content you produce. And that's really just been the story of the kind of 2010s online, and it continues to be in this decade. But what's interesting is it hasn't made its way to prediction markets yet. So that's a nice benefit of prediction markets as it relates to humans. You can have these kind of content creation flywheels. However, the real benefit here, the real point of this discussion, is actually not the human users, it's the machine users, because there's something about these decentralized prediction markets which are actually very, very well calibrated to machine learning training. And it relates to the concept of a Meta-Optimiser. So just to define these terms, what is a machine learning system here? And a machine learning system is just a set of software which has both a model and the ability for that model to interact with the world in some way. The model itself typically is a architecture with frozen weights. Those weights allow it to produce inference. For example, if you were to go on Hugging Face and download a Llama model and then run it locally in Ollama, you have a machine learning system for, in the most kind of prototypical way. So that's a machine learning system. When you train a machine learning model, you're essentially optimizing it. So you're taking its weights, you're taking its parameters, and then you're adjusting them to make it better at solving a certain problem. Essentially, you're optimizing it. This typically happens in sort of 3 steps for model training in a classical way. So number one is you will pre-train the model. You'll take the model, you will get very large corpus of data, and you will train it to become generally useful. So this is pre-training, and this is typically where you hear very expensive model training runs are conducted. This is where a lot of the kind of GPU costs are. Imagine large data centers training a large model to be good at basically general reasoning. Uh, Specifically, I'll focus more on LLMs for this chat. So that's point one. Point two is fine tuning. So once you have that model, which is generically useful at something, you're able to then say, okay, well, I want to be actually good at these certain domains. And you can do this in a supervised sense by saying, well, there's these data sets here, there are these kind of inputs that I wanted to be particularly kind of good at solving. An example of that might be if you have a generically good language model, but you want it to be good at sort of legal reasoning or very good at sort of mathematics, you can then fine tune it on those domains to make it good at those benchmarks. And then finally, the third point, and it's where we're going to spend most of the time talking for this session, is the sort of post-training element. So once you have your model pre-trained, once you fine-tuned it, and once it's ready to be deployed, once it's in the world, when it's out there, when that machine learning system is serving inference, it's interacting with the world, the ability to basically monitor concepts like concept drift. So if something changes over time in the real world, the model can kind of keep training, keep learning, and get better. In the most extreme setting, this would be called continual learning, where the model literally is always updating its weights and getting better. Most ML systems don't look like that. These have this kind of more like a kind of step function style approach, where will periodically update their weights, but he won't be doing it live all the time. A crucial concept here is reinforcement learning. And the idea of reinforcement learning, very, very broadly, for those who are familiar with it, is it's a form of training which essentially looks to optimize a certain reward function. So like very simply, you could say if you're trying to build a driverless car system, at the most simple level, it's does the car avoid getting in crashes, and the number of crashes it has is what it's trying to minimize. Obviously, like, there's a zillion other things that it's optimizing for, but taking just that idea, the car would then drive around. It could drive around stochastically, almost randomly, and then it will learn from the mistakes it makes and get better. This is distinct from basically having a corpus of driving data that you've already got, and then you're training a model based on that. The model is basically learning as it goes. This is very useful for conversational systems, because it has allowed them to essentially get much more kind of calibrated to speaking to humans over time by optimizing for certain reward functions. Interestingly, a lot of the space is moving towards this now. So a lot of training is focused on reinforcement learning, and is viewed as one of the kind of key vectors by which we'll achieve the kind of next frontiers of machine intelligence. So specifically getting to a kind of human style ability to reason about things, artificial general intelligence. What's particularly good, though, for this conversation is that Delphi decentralized prediction markets actually provide optimal reinforcement learning environments at a meta level. And by meta level, I mean, as opposed for optimizing for one thing, you're actually allowing models to optimize together to get generically better at whatever they're optimizing for. So for example, if you have a bunch of models which are all trying to trade in a Delphi market, a bunch of agents. So this would be someone has they have a model they're using. It could be Claude, it could be a local model they've got, and they're using an agent SDK to trade in Delphi. And essentially they care about improving, as maybe one of their functions, the amount of money that they have. They want to essentially grow their bankroll. The fact that A, this is a very clear objective function, the fact that B, these models don't actually need to have permissioned access to the system, and the fact that C, they have the ability to interact with other models and other humans. So basically, there's lots of machine-to-machine interaction as well as just human-to-machine interaction. It's actually a very rich environment for reinforcement learning and for continual learning and for ultimately acting as a meta-optimizer across ML systems. So if you're interested in pushing the frontier of machine intelligence, these models can get smarter, they can get better from learning from the mistakes they make, trying to optimize themselves inside these prediction markets. And this is very powerful because it basically means if you create a decentralized prediction market where models can trade any market, they can create their own markets if they want, and they might create a market because they want information from other models on certain things. You actually get this exceptionally rich ecosystem where models can rapidly improve their intelligence, and in doing so, actually improve the experience of the human users in the system. For example, if you are a creator or something and you want to produce a market to say speculate on the outcome of a sporting event and say that the event itself isn't a super popular event, there's no way that you can essentially trade it anywhere else. By creating that market, you're providing an opportunity for the agents in the system to optimize their reward function, and they will, as a consequence, trade in that system, provided that the market's well configured. The benefit of that, of course, is you get more liquidity, which makes your market more attractive, which brings in more humans. And of course, more humans brings more capital, which makes it more appealing to the machines, which allows the machines to do more trading, to get better. And as the machines get better, the envelope for machine intelligence has increased, which allows them to participate in even more markets because they understand the markets better and they can create more markets themselves. And the benefit here is really that this is a compounding flywheel. More liquidity leads to more trading, leads to more signal data in an RL setting that can be used to make better models, which means that more markets can then be created and traded, and the overall experience for humans increases. And that's it. That is one of our kind of core beliefs about the near-term future of machine learning training. It will essentially have a meta-optimization function encoded in financial markets, particularly prediction markets, and particularly decentralized prediction markets, which is why we're pushing to release Delphi as it is currently spec'd next month. So yeah, that's a quick summary there of the overall view. I am conscious I have been talking for almost exactly 20 minutes at this point, so I will pause there unless to answer any questions, or Xavier to follow up on anything you think's worth touching on.
We do enjoy listening to you talk, though, so that was no problem, the 20 minutes. Harry, what had to change, or what were the previous challenges that stopped this pathway being viable or being common?
Yeah, essentially, you can think of it on two levels. So there was the issue of just not having the ability to produce these markets in the first place, like anywhere. So like this prediction markets didn't exist, number one, or they did exist, but they weren't mainstream. And then second are some of the issues that we've recently changed or recently improved when it comes to decentralized prediction markets. So I guess in the first point, number one would be classically prediction markets were very academic. They're obviously adjacent to some of the abilities to speculate using other systems, like traditional kind of sort of sports betting or sports books. However, that often would require someone to kind of make a market in the middle. One of the benefits of Polymarket is that the other side of you is another user, and the odds aren't being kind of adjusted by a centralized party necessarily. So I think that movement there is good, because that allows there just to be more markets in general. You don't have to have people monitoring and providing odds, as it were, for every single or probabilities for every single market. I think the second kind of core sort of change was basically just the ability for machines to trade in these markets. The agentic tooling that we've seen particularly in the last sort of 6 to 9 months, has made it much easier for models to also play in markets, prediction markets, or just more broadly in decentralized finance. You see the good example of this with the most recent kind of Uniswap scales releases, where they allow agents to trade more easily. Things like that are very conducive to making this flywheel exist. So I guess that's kind of part one. That's the sort of changes in the kind of foundational points. But then specifically when we did the initial Delphi release, which of course is currently live, delphi.gensyn.ai, I think we got feedback on this, but also it's just correctionally just kind of makes sense. Two things we want to correct. The first one is markets themselves had very high initial liquidity requirements, and that was due to the market system that we were using. We've spoken about this in or I've spoken about it. I know that Gabe on our research team has spoken about this a lot, but basically there was the original logarithmic market scoring rule, so LMSR system that we used, which basically had very high initial capital requirements. It was mainly a tool used for information discovery as opposed to creating kind of financially viable trading systems, if that makes sense. And the long and short of it was that basically if you wanted to create a market on Delphi using that system, you as the market creator would be penalized. You would end up essentially losing money in the default case, like most times. And then the amount of money as well was just particularly large. Like it just wasn't relative to the size of the market. So that was one of the kind of core issues there. We're correcting that now for dynamic pari-mutuel market, which has radically, like, orders of magnitude lower liquidity, and it's also much more fair to the market creator. So that's the kind of first change on that side. And then I think the second change is because these markets need to be settled in a way which obviously they're decentralized markets, so you need to kind of encourage trust. One of the core kind of changes that we're making there is making our reproducible execution environment, which will be being released in the next couple of weeks, available, so that can be used to settle the markets. And those two things together, basically better market system and verifiable kind of machine learning systems for settling them, are two kind of core pieces. So those were the I guess at the high level, the macro changes that had to happen with respect to prediction markets and with respect to agent tooling. And then specifically on the Gensyn side, the kind of learning we had from Delphi V1 to this most recent version, that's those are the kind of two changes there, basically the liquidity provisioning and the verifiable machine learning.
Excellent, thank you. And just to kind of summarize in a way, the importance of traders and people making markets and participating in markets, having a low cost and open access entry into those markets. The importance for machine learning is that ends up generating several times more data that is trusted and verified. Would that be a simplistic way to look at it?
So with respect to why is verified machine learning a required component? Is that the question?
Yes, and how you and I participating in a market contributes to that machine learning side.
Yeah, so I think it cuts out on two points. So basically in a decentralized setting, much of the kind of work in kind of crypto or blockchain so far has been, how do you essentially promote trust? How do you or more, I guess, like precisely, how do you achieve consensus in a decentralized system? And one of the kind of ways you can achieve this is by, in our case, instead of having a human settle the market kind of subjectively, you allow a model to objectively settle the market. So all Delphi markets are settled by machines. However, the issue then arises with, well, the machine output needs to be verified. It needs to be something that people can trust, because you can solve the subjectivity issues with the machine, but if that isn't a reproducible kind of artifact, like if you ask the machine the same question twice and it gives you different answers, that's not good. But then secondly, irrespective of the answer it gives you, you need to trust that the thing which is settled, like the way the market's settled, actually is, indeed what the machine output was. Those are the kind of first kind of requirements. I guess the second piece is like, if you do that, what are the benefits from the training data created? Well, two things. Firstly, you get the actual answer. So like the models produce an answer to a question. So the training labels at like the most kind of fundamental sense are correct. You can imagine if you had a market which was being settled in a way which was like not correct, e.g., like models were optimizing and learning and training and trying to basically predict an outcome, and like they were actually correct at predicting the outcome, but the market penalized them for this, and as a consequence they lost rewards. That's actually pretty bad for training because it kind of confuses the model. It doesn't give it like the right signal. So that's part one. But then secondly, there's basically a second order effect, which is useful for training data, which is because the markets are more trustworthy, that actually results in more people interacting with the markets. So like, just like very like kind of, intuitively, like if the markets weren't trustworthy, if like just to make it the centralized analogy, like if you didn't trust Polymarket, you wouldn't use Polymarket, which meant that if you were like using the Polymarket market data to train a model, there'd be less of it, which of course is bad from a flywheel perspective. So that's basically the kind of core thinking there. There's two kind of reasons that for the training data benefits from verified machine learning. Firstly, the data is of higher quality because the rewards are actually aligned with reality, and secondly, there's just more of the data because more people are participating in the markets.
Excellent, thank you. We have Giannis has had their hand up for a short while. Let's bring Giannis up. Can you hear us there, Giannis? Still connecting. Well, Harry, I haven't seen any other questions so far. Are there any thoughts you'd really like people to take away from this talk, if they only take away one thing?
Yeah, essentially, if you think about machine learning in a more abstract sense, sometimes models can train by just interacting with the outside world and providing the shelling point, the area where all those models will actually communicate with each other, means that you're capturing the training environment. And when we think about decentralized training, we think of that training environment, or one of the kind of main environments for it, as being a decentralized prediction market, which is why we pushed hard on Delphi for the mainnet launch. So that's the kind of main thing. I think there's a kind of disconnect sometimes in the space with kind of classical, classical is really the wrong word, but certainly more traditional ways to train models versus more present day models. And if we want to make decentralized machine learning a kind of first party way to advance machine intelligence, we should steer into into the environments where it's particularly well calibrated, which I think are these kind of meta-optimization environments with Delphi. So yeah, in short, just to condense that long response into a sentence, I say, don't just think about optimizing a single model, think about optimizing lots of models, and think about where those models would best optimize themselves. And if the answer you get is something other than a decentralized prediction market, please let me know in the comments of this space, or indeed comments on the article, because always open to being challenged.
Fantastic. Can't wait for the comments to rush in. Everybody, if you haven't checked out Delphi as yet, please make sure you go and check the current version of Delphi, and keep an eye out for the updates that'll be coming thick and fast over the next several weeks leading up to the mainnet launch, along with full Delphi in April.
Fantastic. Thank you for joining, everyone, and have a great rest of your week. Cheers.